Hello everyone. So today we are going to discuss the topic segmentation in operating system. So I hope you are already familiar with the concept of paging. If you are not aware of that, please go to the previous video. It is about paging. So we are continuing that session because segmentation is a topic which is a continuation of paging. It's a bit deeper topic into the paging. Okay, so the segmentation uses the same concept of paging, but the only difference here is that uh, I hope you remember in paging the entire process was split into n number of pages, and those pages were in secondary storage and it was copied into the primary storage, where each those partitions were called frames. Yes, and in secondary storage it was called pages. So it is the same concept here also, but the only difference is that there the each size of the each page was constant. Okay, if one page was of 1 KB, then all other pages would have been of the same size of 1 KB. Okay, so same would have been the size of the frame in our RAM. Okay, so that is the basic difference between segmentation and paging. Here the page sizes are different, and because it is of different sizes, we are not calling it as a page, rather we are calling it as segment. Okay, so here the concept is very similar to paging, but with the different size of pages. So because as we take a book, all pages are of the same size, so that concept doesn't suit here, so we are altering the term being used here to the segment. Now why are the segments of the different size? Let's say we have a program and it has a function a, right? Here a set of lines, and here the function, let's say a has a number of line of codes of 2000, and b, we have another function, it has a set of line of code of, let's say, some 100 line of code. Okay, now what happens if we are using the concept of paging? We are creating a page which must be able to accumulate this process or this section. Now what happens in paging is that we are making a page, we are making n number of pages with a fixed size. Let's say each page can accumulate 500 line of code. Okay, 500 line of code, and so that will be okay. As far as a process is concerned, we can get this a function, we can just split it up into 4 sections, and we can fix those 4 sections in 4 pages, right? And again one more page we can add where we can save the b function. Okay, so these 4 will altogether contribute a function. So that all is okay, but what happens during the runtime is that the CPU has to again and again jump from one page to the other page only for the sake of executing the entire set of code. No, that is not an excuse, right? So that consumes a lot of time. It increases the complexity, time complexity and space complexity. So what the segmentation process does is it selectively prepares each page for each process. If the process, let's say if the process has 2000 line of codes, then the operating system will be allocating a segment in the main memory with 2000 line of code for a function. Now if the next function has only 100 line of code, why should it allocate such a large space for such a small program? So what operating system does is that it just provides a small section with 100 line of code space for the b process. Okay, so what happens here is that there is no requirement of jumping from one frame to other frame as it was in the case of paging. It consumes a lot of time. Here all 2000 line of code is available in a single stretch, so the CPU saves a lot of time where it need not jump, need not go to other address, it need not refer the page table, it can just keep on executing the line of codes. Okay, so this is the beauty of segmentation. Now as in the case of paging, there were page tables were used. So similarly here in segmentation also we are using a table which is called segment table. Okay, segment table is used. Now a segment table consists of 3 columns which has the name of the segments. Here for example we have allocated S0 to S6, so these are the names of the segments, and that segment can be identified with the help of these names. Okay, So the second column consists of the base address. The base address is something that refers to the main memory. Okay, let's say if we have a segment starting from 0, so the base address will be 0 for how much length the RAM has been allocated that segment or that memory size. That size is represented by this value or 200 in our example. That is, if a segment starts from 0 memory location in the primary memory, it can go up to 200th location in the main memory, okay, in the primary memory. So that determines the size of a segment, that how long or how lengthy the segment is in the main memory. So these are the three columns that can be used in the segment table. Okay, for example, we have a segment table here where the S0 is the first segment that we have, that starts from 0 base address and has a size of 200. Okay, so from the beginning, that is from the address location 0, we can get the S0 process or S0 segment. Okay, you can go up to 200th position, that 200th location. Okay, now we have to see which is the next one. Next one is S1 segment that starts from the base address 1000. Okay, so here's the base address 1000. From here the process or the segment starts. Which is the segment? It is S1. It can go up to how much? Up to 100 spaces. Okay, so it starts from 1000 and goes up to 1100. Okay, it starts from 1000, it goes to 1100 because the size is around only 100 memory locations are required. Okay, next one is S2. S2 starts from 200 and the size is 500. Okay, S2 starts from 200, its size goes on to 500, so we have up to 700 location. Okay, so here is S2 location. Next is S3. It starts from 1100. Okay, from S3 starts from 1100, goes up to 200 positions, that is up to 1300. Okay, fine. So S3 is located between 1100 and 1300. S4 starts from 700. Okay, it goes up to 300 memory locations, that is up to 1000. Okay, next is S5. It starts from 1600. Okay, S5 starts from 1600 and it goes up to 1000 locations, that is 1600 plus 1000, that is 7 till 1700th location. Okay, and the last one is S6. It starts from 1300th location and goes up to 300 locations, that is up to 1600. Okay, so this is how the segments can be arranged or may be arranged in the main memory. The thing to be noted here is that it is not at all sequential. Okay, now we have been saying that in the concept of paging itself we are talking about non-contiguous memory allocation. So it may not be continuous, it may not be sequential, it may not be even filled adjacent to each other. Though it is not continuous, still it may not be arranged adjacent to each other, it may be just scattered over the RAM. Okay, on what matters is that the beginning address and the size. If we have the beginning address and the size, we can easily get access to the physical address, okay, to the main memory. So coming to the basic architecture of segmentation, so here it is. The CPU generates the logical address. We had already discussed there are two types of addresses. One is logical address and one is physical address. CPU cannot generate physical address directly. It can only generate the logical address. Logical address stands for the address in the secondary storage. Okay, so as in the case of paging, we had two sections. Here again we have two sections. Only difference is that in paging here was the page number, in segmentation here is the segment number. That is the only difference. Okay, and the second section of that address is the instruction offset, the same thing as we had discussed in the paging. Okay, so the instruction offset can be reused in the frame address, because as you know, the segment size and the corresponding frame size are of the equal size, right? It is not identical to each other, they are not identical to each other, but still if you are saying S2 segment, it will be having a size of 500. So similarly here also S2 is having the size of 500, 200 to 700, so size is 500. So the instruction offset or the number of instruction, the nth instruction will remain the same. If it is the third instruction in this segment table, it will be the third instruction in the page or sorry, if it is the third instruction in the segment, it will be the third instruction in the frame as well. Okay, so that remains the same. The change comes at the segment, right? In segment we are using the segment table, and similar table will be placed here, and we'll be just going through which segment do we require. If we require, let's say if we require S1, so corresponding base address will be derived, then corresponding size will be derived, and then the physical address will be generated. Okay, from this table we can generate the frame address, and offset we are already having it, so the resultant will be the physical address. Okay, the last thing to be discussed is the size. How is size relevant here? Okay, the only criteria is that the CPU must not keep on accessing the whole main memory, right? There must be certain limitation. Let's say if CPU has started accessing it from 0, it must stop accessing at 200th location, because only S0 is required at that time. It must not continue keep on going and accessing each and every segment thereon. Then there will be no use of segmentation, right? So if CPU has to access S4 segment, then it must start from 700 and it must stop at 1000, right? So there comes a major role for this size. The condition that we provide in the CPU execution is that D must be less than size. It must not be less than or equal to. Equal to is not eligible here. It must be mandatorily, D must be less than size. Now what is D? D is the offset that we can be provided by the CPU. D is the offset that can be provided by the CPU. Okay, so this must be less than size. Okay, let's say we have D's value as for instance, let us consider some segment S5, right? S5, and S5 D's value, let's consider it is some 56, right? With the size of 56, we can place it here, that is 56 is less than, what is the size of S5? We can simply go here and refer, size of S5 is 100, right? So the 56 is less than 100, okay, condition is true, then only the access is provided. So the CPU has access only um, from starting from here up to 56th location, okay, 56th memory location. So that is the restriction that it can be provided, because there is no need of, if the CPU needs access only till 56, why should it go further and execute remaining 44 instructions also? So it is not required, it is just a wastage of time, right? So the CPU has been kept on hold with a limitation that it has to satisfy this criteria, that is D must be less than size, and whatever the size of D, if it is 56, then it need to execute only till 56. It need not execute the 57th, 58th and 59th and so on remaining instructions. It saves a considerable amount of time by not executing the remaining 44 instructions or 44 memory locations, right? So that is the beauty of segmentation. And if you are taking one segment, let's say if you're taking S1, then in case of paging it would have been further splitted into certain more pages, but that is not the case here. Here the segment is created based on the program, so hence certain split within the process is not at all recommended here in segmentation. So this is the basic concept of segmentation. I hope the concept is clear. Thanks for joining. See you in the next class. Thank you.